if we are ready and if Dr. Amrita is ready, then we can begin our final session of this two-day international conference. I would now like to hand over the time and the session to Dr. Amrita Stha.
Welcome back, everyone. We're going to start the final session for today. And we'll be starting with vacuum dressing research. Dr. Arjan Knulst, he got sick. So Dr. Suraj Maharjan will be presenting on vacuum dressing research. He's a consultant plastic and reconstructive surgeon, leprosy and physical disability service lead at Green Pastures Hospital. He is dedicated, he's a dedicated surgeon in rehabilitative surgery in leprosy, wound care, and other physical disabilities. He has special interest in clinical research. Yeah. Oh, yes. Yeah, there he is. And he's also my husband. Let's welcome him.
Thank you so much for a wonderful introduction from my wife. I was not expecting this. Someone was supposed to come and present, but Arjan, if you're online listening, I'm doing it for the team, for us. So you see a long list of authors here. The title shows WOCA. Any guesses what WOCA is? No? It's wound care. W-O, wound, C-A, care. So this is a vacuum wound care device that we designed for wound care in low resource setting like ours, especially in Target, if we can use this in community practice, community nursing care. I'm delighted to be on the podium, which I was not expecting. I am a biomedical engineer for a day, but if you ask any questions about biomedical engineering, I'll have to pass this on to Arjan, who is online, who is sick, by the way. Get well soon, Arjan. This project was made possible through Sunita project with kind contribution on developing a vac machine. We did develop 3 prototypes, but I want to take back to the journey where we started. Sorry, I'm turning the clock. I think nobody was expecting, because it was all a bit of more palliative. I'm taking this to a physical wound now. So this all started with meeting with Arjan, a biomedical engineer who joined Green Pastures in 2019. So as I was very interested in wound dressing, so I met him, and we had something called Turtle Vac. It's a vacuum pump that is used for aquarium. So we were using that for vacuum dressing at Green Pastures. So I showed it to him. He came up with the idea, why don't we make something like this, which we can use it with. It can be a portable device. It can be carried by a patient. It can be used in a community level. Before I move on to this next slide, this is what Green Pastures and Pokhara looks like. So this is a beautiful place. I love this place. We love this place. This is Annapurna Range that you see every morning. If sky is clear, the weather is good. And you see this is the aerial view of Green Pastures, a beautiful place with a palliative care and chronic disease center at the down. And you also see the old courtyard of Green Pastures, where leprosy work started in 1957. We have something like an ear-shaped building on the what side? Left side. So that's ear center, where we do ear disability. Just to tell you about the Project AIM, it was We're planning for a low-cost design of a machine with high performance, safe, which is portable, and which can be locally produced. And locally produced means I'm trying to sell this product. If you're interested, you can sign up after my presentation. So this is a normal vac dressing that's shown here, where you have a sponge and a transparent sealing membrane, and which is attached to a machine pump, which is a negative pressure, which sucks the exudates and which helps in wound dressing. So it affects, it increase in wound healing rates, decrease wound complications. But the obstacles we see in Nepal or low and middle income countries, it's not available. It's too expensive if it's available. It's around 20 lakhs. Or existing low cost option is not that great, not what we have. So I'll show you what we have. So this is me in surgical theater trying to install a vacuum pump, which we have. So it's teeny tiny, what you've seen here. I've tried to debride a wound, which was referred to me from an orthopedic surgeon. So he was scared of amputation, so he came to me. So this was the wound dressing I did, was sealing with a transparent dressing material. It was like this, which is attached to a vacuum pump, which looks like this. So this is what we have, a traditional aquarium pump, which is used as which is reversely, what do you call? I'm not an engineer here. So it's used pump is used in a reverse way, so you can do a vacuum, and it is a bit messy, you see, and it's not a portable device, and it doesn't have a pressure control and no alarm system. So our requirement was to have a simple function like stable pressure, pressure setting adjustable of minus 75 to 125 millimeter of mercury, pressure control plus minus 10% of set pressure, which can be portable and which can be battery operated. As we know that we have power cuts, still we do have power cuts. So it'd be awesome if we had something with battery power, which can be used for 5 days continuous without charge. So it had we developed safety features with pressure control, alarms, overflow protection, and which can be repairable. So we had estimated cost around 30,000 Nepalese rupees. So yeah, Walker designed, it's wound care design, the machine. So the total cost was around approximately 25,000. So we met the requirement. The components were available in Daraz, AliExpress, and it was made in green pastures. So this is made in green pastures. And so with biomedical engineering team, they did all the verified requirements. 3 prototypes were funded by Sunita. So I won't be able to answer any questions if you ask this. This is more technical. It's got a vacuum device which will be attached to a dressing set. It's got LED lights, alarms, control knob, switch, charging port, exhaust filter, bacteria filter, everything. So this is what it looks like inside. And after it's built, it looks something like this. So Arjan's got a small portable 3D printer. So he printed all these components. Amazing. So this was technical performance. We did pressure control tests and leakage tests. So this was then tried in various places. So we went to Circuit, our shining hospital in the West. Did some training with nurses there. again in green pastures in palliative care unit. We tried with one of our volunteer nurses who came for training. And again, a healthy subject test. This is one of our recent biomedical student who did all other testing. So we tried on his hand as well. It worked perfect. So later this was, the design was published in open access journal. So we had required parts, building instructions, testing instructions, which is published in this hardware journal. So pretty much we can use it clinically. So this is what Walker user interface looks like. And in conclusion, I would like to conclude, Walker vac therapy design provides safe and stable vacuum for vacuum therapy. It'll allow treatment in hospital setting as well as community setting. So it's open access design, which we publish, allows reproduction by anyone. So now the clinical evaluation is needed. So we are pending for NHRC approval for our clinical application of this device. With this, I would like to thank the whole team who were involved, especially those biomedical engineers from Delft University, with whom we've collaborated. A few of them graduated during COVID. Few of them came with a prototype, with designs and again, all validation. So I'd like to thank the whole team and also thank Sunita for giving this opportunity to build this local product, which can be utilized in future in hospital setting as well as in community setting. Thank you.
Thank you, Dr. Maharjan. We have Dr. Arjan on screen if anybody has any questions.
I hope I did a good presentation, Arjan.
Yeah, thank you.
Any comments from you?
Excellent biomedical engineer for a day.
Do we have any questions?
Do you have any comments or questions, Arjan?
No, not really. I think that the most important thing is to move this forward. We need to do some clinical testing to make sure that in real clinical life this is also working. Because so far we have only tested in like lab conditions, using test equipment, using healthy subjects. And before we can routinely use, we should proceed towards some clinical validation. And the whole idea of this design is, so it's available for everyone. So anyone who has some basic technical skills, who has access to the parts, which are available, for instance, in Nepal or in Africa, or wherever in the world, they can build the device according to instructions and they can test it to verify it is working well. And then they can use it in clinical practice, which includes community work because of the battery. And the battery is designed such that it can do like a complete treatment cycle, about 5 days of treatment on a single battery charge. So that fits well with the community practice. I think that's my addition to Dr. Suraj's presentation.
Thank you very much. Thank you very much, Arjan. And
so I'd like to acknowledge Dr. Ruth here, because I had to convince her to fund for this project. So thank you, Dr. Ruth, and also Sister Manju. So yeah, I learned a lot about palliative care. It was more about physical healing. It's more than that. Thank you so much.
thank you.